This computer, we're recording. And a quick thank you to Samson, a company that makes all sorts of audio equipment, for giving me this free stuff to try today. It actually works, although the headset's a little uncomfortable, but it's only $100 as opposed to the lav mic system I had last time, which was, I think, like a $2,000 system or something. I don't recommend their one that's like the lapel lav one, because it's either the pop filter or it's the mic itself. It picks up too much collar noise. But this headset thing, it's working really slick, and even better, I'm not having to worry about ground loop noise because I don't have to plug in this tiny little dongle sticking out of my laptop. That's the entire receiver for this pack on my back. And now I won't have nearly lose the whole recording to leaving my laptop unplugged. So yeah. All right, so yeah, I personally found Python after trying to do some batch scripting. I really wish there were a clicker, but everybody always loses the clickers in these rooms. Should have asked about that when I first got here. So I'm going to be walking in front of the screen a lot and trying not to block it too much. Let's see. Oh, okay, I got a question from the chat asking why I'm wanting to do this seminar. And I am wanting to do this seminar because I'm so excited about the things I've been able to do with Python without having to worry about too much code, without having to install a lot of stuff on my computer. So I was looking for something back when I did not have a whole lot of responsibilities for programming here at St. Thomas. And yet at the same time, I did want to take spreadsheets and put them together. And I started out using batch programming because, again, it comes with every version of Windows. You can just sort of write code and run it without having administrator rights to your work computer. But I wanted something else, and I was looking through, just Googling recommendations for working with spreadsheets that maybe didn't require installation privileges for Windows. And I found something, at the time I think I was using something called WinPython, Portable Python. And there's another one called WinPython. They've gotten a little long in the tooth. There's a new environment called Anaconda, which does require administrator rights to your computer, but on the other hand, it makes everything a lot easier these days than some of those old ones that need you to have a newer version of Windows to run anyway, for which you do have to have administrator rights. So I'm not quite sure that holds true anymore, of not having to have administrator rights with Python. But at the time, it was a very easy way to be able to code it in a way that was not quite as brutal as coding with batch programming. And the three main things that I've decided, because Salesforce, you always hear the phrase "clicks, not code," and so I think it's largely still the same when it comes to modifying spreadsheets. There's no good reason to just delete a single column, to write a whole program to delete one column from a spreadsheet. If you can open it in Excel, delete the column, hit save, and you're off to the races. And I think also, if you have a 10-step process and only one of those 10 steps is hard, great. Do the first 5 steps in Excel, save your file, do the next step in Python, save your file, open it up in Excel, and do the last 4 steps. That's fine. I do that all the time. But that's what you do? Yeah. But I think there's really 3 cases in which I think it's time to code, and specifically in which I think Python is the easiest form of code I've found for doing that. Number one is really, really large files. And if you've got a file with 1 million lines and you try to open it in Excel, it's going to take you a minute to open it. Then you filter it. That kind of goes all right. But as soon as you then delete some of those rows, and it'll like hang. And then as soon as you try to unfilter it, it'll hang. Maybe even freeze up your whole computer. And that's actually not because deleting the rows is so hard. It's because Excel is trying to redraw all of those deletions it just did, and like all the 1 million rows below the deletions you did, and move them up a couple pixels, move them up a couple pixels again, move them up a couple pixels. And so if you code, the bad news is that you can't see the code changing your files. The good news is you can't see your code changing the files, and it's going to go in a matter of seconds, or with really, really large data, maybe a matter of minutes, but it's probably not even going to freeze your computer while it thinks, so you can watch a cat video on YouTube while it takes a couple of minutes. So size is a really big thing. Second one is repetition and automation. It can be really nice to basically teach your pet robot to repeat after you. And so there was a time when I needed to explore a large file. It was a dump of our contacts table. I knew maybe about 20,000 records had something off about them because we had changed from a process and formula fields to a trigger, but we had also changed the business logic a little bit in the meantime. And so I was just looking for field A and field B. Where are they different? Or where does field B say it can't compute a good answer? And try to figure out what's going on in the data so that I can run that by the business users and say, hey, did you know that we're still not computing it when somebody is from Kansas and doesn't have a high school on file? Or when somebody is from Oregon, did you know that the old way and the new way are different? Is that okay? Is the new way actually coming out correct? So I needed to basically look for data, look for sort of figure out why it was the way it was, and then just add a flag in a column at the end saying, reviewed this, don't worry about it, or this is error category A, this is error category B. And so I could have done all that in Excel and it wouldn't have been so bad, but it was a little annoying every time I wanted to sort of clear out things I'd already flagged. I had to, clear all my filters and, then set that final one of saying, okay, should still be blank and whatever. But it was the biggest thing was that I was pretty sure that other people were in the middle of modifying a lot of data that day, and that I might have to start over halfway through the day with a fresh download of the contacts table. So as I worked, each time I came up with a rule saying, okay, if Kansas and no high school equals category A flag, I would type that into a Python script. And sure enough, somebody told me middle of the day, hey, you got to start over. And so I was able to just download the contacts table, run the Python script against the fresh download, and 10 minutes later, pick up right where I had left off with fresh data. So automation, repetition, another really good reason to code even the simplest of steps. If you think you might have to do it again and it would be really, really painful to do it again. I got a question in the chat room saying, what do I like about Python over VBA? Simplicity. I think that VBA is, I never learned to use it because, for example, if you want to grab a column where it says first name, but you don't necessarily know which column that will be, or you have to literally write code to loop through line 1 and then put the letter that you find in a variable so that you can later refer to it in code. Python has this module called Pandas that just makes it easy to type in first name, and it will take care of that. All of that looping and stuff to do it, it puts that behind the scenes. You just say, I want the first name column. So great question. That's what I really like about Python over VBA. And situation number 3 that I like about coding, as opposed to doing things in Excel, is merging tables, which is what we're going to get into some today. VLOOKUP is a pain. It's not even something where you can really say that it's easier than what we're going to do today. Okay, so who here has done a VLOOKUP? Okay, we've got just about every hand in the class up. Who here could recite to me the syntax for VLOOKUP? Okay, that's a lot more hands than I thought. About half the class. I can't. I would have to Google what you do to VLOOKUP. And so I personally prefer Python because it's a lot more like SQL for those who have used it. It's just a lot more intuitive way of saying, I have this data and I want that data. The other thing is it sort of takes the whole table and puts them together at once, more like SQL does, or going into Microsoft Access and importing 2 tables from spreadsheets and doing the joins to put them together. You don't just, every time you type, only get access to one column from your second spreadsheet. You get the whole spreadsheet put together, and it's much easier to do things on multiple columns at once as your join criterion. So we just talked about some of that. We got a little bit of what do people wish they could do. I'd love to hear from the chat room if anybody has any other business problems. But today what we'll do is just a quick recap of what we learned 3 months ago. So everybody remembers it like it was yesterday, right? It was yesterday for you. Excellent. And we covered a little bit of adding and dropping columns last time, but it's so important for combining spreadsheets because, as I said, when you put together the spreadsheets, you sort of get everything. You get all the columns from table 1 and all the columns from table 2, and that might not be what you want in your output. So it's really handy to be able to add, drop, rename, and reorder columns so that you can actually get the output you're looking for. And we'll talk about some, we're going to put tables together. We're going to hopefully get to row filtering and then selectively editing cells and maybe even doing a simple pivot just to get some statistics about, say, people coming to these classes. So the thing that I want to mention is that there's a big culture shift in the way I taught 101 versus the way I taught 102. I think you said in 101 that it was really easy, and I can't promise it's going to be quite that easy today. And the reason is mostly that I want to sort of show you the other extreme of why you're learning all this. Because what we did in 101 was I sort of took you on a tour of the kitchen and I said, This is a pot. This is a pan. This is a big spoon. It's for stirring. This is a little spoon. It's for eating. And I don't know if anybody came out of 101 actually being able to get any food on the table when the kids are screaming. And as opposed to, and we could keep going that way. And then I could get through to things like you want to use a wooden spoon for stirring spaghetti sauce because metal and tomatoes react and may make your sauce sour if you use a metal spoon. And we could go that way through all that stuff until you're on MasterChef and can just improvise anything you want in Python, and it would be years. So what I want to show you that Python is so famous for, this cartoon we've got says Python. This is if programming languages were essays, and this goes around a lot, and it says, it's got the teacher saying to the student, this is plagiarism, you can't just import essay. Python is famous for being canned soup and frozen dinners. That is exactly why people love it. And one thing that we do at my house that I find hilarious is my husband taught me a quick way to put food on the table is you take 2 cans of soup that look like they kind of might go together. You take like a frozen rice bowl and you microwave the frozen rice bowl, you dump it in with the 2 cans of soup, you heat it up, and then you maybe take some spinach out of a bag that you got in the salad aisle, and you chop 1 tomato and you throw it in, and you put it on the table, and you're just like, look what I made. And that's kind of what we do with Python. On the other hand, there is some cooking knowledge that goes into knowing that spinach and tomatoes taste good in soup, and that knowing, that rice is going to taste good and fill out a soup. So is everybody going to feel like they're all the way there today and really know how to put this stuff when I just throw some cans of soup on the table and say, make a meal? Not necessarily. So we're going to have a couple of ways. We're going to sort of work through examples together. I'm not going to just like put code on the screen and say, type this. It's going to be more like, we'll talk together about, here's what I want us to do. And even if you can't remember the syntax, what kind of thing have we seen that maybe might be useful if only I could remember how to type it. And for some of the harder stuff, we'll even have a collaborative programming environment that you can get into. All right. So coding 101. We talked really fast about, or we talked about the fact that expressions are more like formulas in formula fields and in Excel. They are code that become a value. Statements, they don't have a value when they're done running, but they do stuff. They put stuff on your screen, they save a value into a piece of code that you can later use. And as you can see, you often do one thing to turn an expression into a statement. The expressions are the heart of actually computing anything interesting, but the statements make it happen. So a statement is to a program as a sentence is to an essay. You're generally going to have 1 per line, and they're not really nestable inside each other, whereas expressions are nestable inside each other. You can have something like 1 plus 3, is it or is it not less than 2 divided by 3? Variables are like your wet and dry bowls when you're cooking. They're just a place where you can do something really complicated with an expression and say, I do not want to have to type that again, or I don't want to have to get into parentheses hell like I do in Excel. And so you can just save it off and give it a cool name, and then later on when you type that name in your code, it just stands in for that value. You can pick anything that isn't already a Python command. And one big thing to keep in mind is that commands and variables and stuff, they don't have quotes around them. Things that you actually mean to treat as text, they do have quotes around them. You can use single quotes or double quotes. I personally find that I use double quotes more when I'm typing, like in the actual text, than I do apostrophes. So I tend to use single quotes because that way I don't have to do the weird backslash thing every time I type an apostrophe. Well, I have to do the weird backslash thing every time I type an apostrophe, but I don't have to do it every time I type a double quote. So either type of quote works. There are things you can do if you need quotes inside of quotes. Pick your style. My style is single quotes. Yeah. It is. You're welcome. Yeah. 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 Python is meant to be a sort of an easy to read scripting language in many domains. So yeah, when you're coding, as opposed to when you're working in Excel, you type a formula in Excel and you move to a new tab, you can see what that value is. Whereas if you type 1 + 1 on a line as if it were a statement and hit run, it'll just be like, okay, I'm done running. You're like, what happened to 2? Well, you didn't tell it to do anything with 2. So that's what makes things fast, but it's also a little bit of a paradigm shift if you're used to Excel. So that's why we're going to see so many print statements, is when we want to actually see what we just did. So a little bit to get used to there. If everybody could just pull up this website, link.stthomas.edu/sfpy hello. And it's going to take you over to a online IDE. For all practical purposes, an IDE, integrated development environment. For what we're doing, it's a text editor with a run button and an output area. It's something that understands what Python code means when you hit run. And we have this wonderful online one called repl.it, and we're going to use that a lot today. Please, please, please never use this with data that is from your company. Always make up sample data that's completely phony when you're just experimenting in an online IDE. You're going to want to, you can talk to me after class, over break. I can do another office hours if you'd like help getting it installed on your computer so that you actually have an IDE on your computer and you can actually run Python natively on your computer, which is a lot safer way to deal with spreadsheets that you've actually exported from Salesforce. So I just need you to know that I have no idea who's watching at the other end of this. So it's really important never to punch in sensitive data. So if you just hit the big green run button, you should be able to see hello world, right? Is there anybody who has not gotten that to work yet? Okay. Everybody's gotten it to work? All right. So now backspace hello world and change it to yay us and run it again. And raise your hand and give me a little yay us when you're done. All right. So does everybody in the room have it? Okay. We're going to say yay us really loud on 3. 1, 2, 3. Yay us! All right. Thank you. That's totally my hashtag for these classes now. All right. So for the most part, data types are a thing that you're already familiar with from Salesforce when you set up what a field's type is. And you have some sort of intuitive understanding that you can't divide text by text, but that sometimes when you put a plus between pieces of text, it acts as concatenation, but if you put it between numbers, it acts as addition. Data type makes a difference about what it is that you can do. And so I like to think of it in 0 dimensions, 1 dimension, and 2 dimensions. 0 dimension, it's a point. It's what's inside of a cell in a spreadsheet. 1 dimension, it's a line. It could either be a row, which in spreadsheet land is special because that means it's all like the same person, the same transaction, it's the same thing of whatever it is all the rows mean. There are 2 forms of 2-dimensional data where that's not necessarily the case. And then similarly, there's a special thing about table data where the vertical 1-dimensional data, you can pretty much count on it usually being the same data type from cell to cell to cell, that it's like it's a first name all the way down across records. And then we have 2-dimensional, which is the whole table at once, or like a couple of columns and a couple of cells, sort of, you sort of drag or you click a bunch of cells randomly. It's that's also 2-dimensional data. And so there are things that you can't take the average, you can't, what was I going to say? It doesn't necessarily make a lot of sense to take the average of the number 4. I mean, it is 4, you can do it, but you don't care about it. Whereas like if you have a list of numbers, now you care about the average of those numbers perhaps. So there are aggregations that make sense there, but you can't inherently divide a list by 5. There are ways to interpret that might be the case, but what you have to keep in mind is that you actually have to interpret it. Does it mean that you take every item in the list and divide them each by 5 and produce a list of the same size, but where everything has been divided by 5? Does it mean that you select every 5th member of the list? Things like that. So the dimensionality of data also not just the type of the data inside of it impacts what makes sense to do to that data. And so we have two different types of one-dimensional data that we'll deal with in this class, one of which is just a list. It's the basic list that comes in Python. And you'll see it's always in square brackets. The other kind is a series, and that's part of this plugin, this module that's an extended set of commands for Python called Pandas. And those things, they understand more, that they're not just a list, that they're magic, that they're either a row or they're a column, that there are things that you might want to do to them that are implicit, useful business operations for dealing with slices of tables. And then the same thing with a data frame. A data frame represents a table, or it could represent a smaller table, like a fragment of your table. But either way, there are commands that the code will implicitly understand you might want to do, seeing as this is a table full of data. So a data frame looks like this one at the top. Generally, if you print it onto your screen, it'll, across the top, it'll have the names of the columns, and along the left, it'll have the row IDs. I'm not going to call them row numbers because that implies that they work like in Excel, where they're always in the same place no matter how you resort the data. In this case, they really tend to, they tend to be more like they start with 0 when you first import your table, but if you reorganize them, 0 will follow the data it was with, unless you explicitly give a command to no, start over, renumber everything from 0. So I like to think of them a little bit more as row IDs. And then a series will also have item IDs. They're not, you can call them row IDs if it's a series representing a column. That makes a lot of sense. But I just also want to say this, I'm also going to call them item IDs, because if it's a series representing a row, then the IDs are the names of the columns. So row ID doesn't really make sense. So I'm going to call it item IDs. And yeah. There is a command in Python called type. You put it around any expression, and then the result of that is some text telling you what type of data it is. We were just talking about data type. If you need to know, then yay, you can just put it around hello world, and it'll say class str. And this is very Googleable, which is great, because sometimes weird things will come out of playing with Pandas spreadsheets, and that way, if you need to know what you can do with it next, just put type around whatever came out, and then you have a thing you can Google, and you can learn all the commands that are related to that. We also made sure that we could even get a CSV file into our IDE and put it on the screen. So let's do that. Let's go to link.stthomas.edu/sfpy files all together. And oh yeah, I'm supposed to explain the code already on the screen. So import pandas on that first line. That just means that we're going to be using commands from the pandas plugin. That if we were to just start talking about data frames and series, native Python wouldn't know what we were talking about. So we need to say, hey, we're going to be using a lot of commands that are from the pandas world. Then I like to do this set option thing that if I didn't do it, it wouldn't take it. The computer would not take advantage of all of the space available on the right-hand side of the screen, and it would potentially make data wrap when it doesn't actually have to. So that's just a setting I like to set for my personal visual purposes. And then we've got 4 variables that I am setting the values of, and I'm just saying I've got 4 file paths. They each go out to the web and pull down sample1, sample2, sample3, or sample4.csv. And that way, instead of typing this long piece of text, I can just type file path 1 later on if I want to use it. So you're going to add to the very bottom of that 4 lines of code. You're going to say df1, and it's very conventional in the world of dealing with pandas to take anything that is producing a data frame and put it into a variable that is the word df, or that starts with df or ends with df. So df1 equals pandas.read_CSV file path 1. And then on a new line, you're going to hit print df1 so that you can see what it looks like. And then on the next line, you're going to hit print and then a little open quote and then just some lines and a close quote, just so that when you're printing these things back to back, they won't all run together in the output. And then a new line, and you're going to say print and then quote there. And this is just like building a formula in Excel or in formula fields. You know, if you want spaces in there as you put things in the middle of the sentence, you're going to have to put the spaces in as part of your text. So there are space, close quote, plus. And then what we're doing is when we compute, we're going to count the number of rows in that data frame just by putting the word LEN for length around it. But then that's a number, and Python yells at you if you try to put a number right into the middle of a bunch of text. And so we have to explicitly say, okay, turn that number into text, please, by surrounding it with str, which stands for string, which is what programmers like to call text. Because, I don't know, they just do. Probably, yeah. Yeah. All right, so if we add that, I don't actually know if this is good. My code never copies and pastes well from my PowerPoint, but we'll see. So the reason this sometimes takes a little while on your first run is that it is literally firing up an entire web server just for you and installing Python on it and installing Pandas on it. And since I did not start typing earlier, now it's got to do all that. And so what we're expecting to see is the output of our table and an announcement that there are 7 rows. I guess what I'm more curious about actually than running it myself is, has anybody had any trouble getting this on the screen? Because my principle here is I do not want any student left behind. We can learn half as much as I promised we were going to learn, but I want everybody to learn what we learned today. So everybody got their 7 rows and they got an output? Okay, great. All right, so some commands we practiced. We said import pandas, and we did pandas.read_CSV, and then we would put some text indicating where to find the file. As I said, sometimes certain characters are special, like this thing. Like if you want them to be treated, because they're special, if you want them to be treated as normal, you have to put a backslash in front of them. Well, guess what? Backslash, being the thing that means this is special, is special. So you have to do a double backslash. So this is just getting to the yay file, yay folder on my C drive. That's why it looks a little bit different than it would in a normal context with just one backslash. And then I'm just saving those files into variable names. There's also a read Excel, which is great. Might act a little unpredictably if it's a really weird Excel file with a lot of like grouped cells and merged cells and stuff, but as long as it's pretty straightforward, it doesn't really care about what you bold-faced or what you highlighted red or anything like that. If it's a pretty straightforward table, it's going to read it just fine. Yeah. Yes, it does. Question was, does it read older XLS files? Okay, so if you want to grab a column, let's say we've got John Doe, Jane Dill, and Mick Jag. This is a transaction log. This isn't a log of people. This is a transaction log of all of the things that they've been registering for here at the university. And so if you want to just grab that column D and have it as a single series, you're just gonna, let's say that we had imported this whole table as df4. You do df4 and then an open square bracket and a closed square bracket, and in between you're just going to, and you're going to need your little text indicators. You're going to put the name of the column. And so again, remember, it's just an expression. If we don't print it, run to CSV, save it into a variable, it's going bye-bye. So some things that we can do with df call name, and you can feel free to pull that up and run it if you'd like. It's actually going to run stuff from a bunch of slides, but sorry? A series, because it's just the one column. Now there is a thing you can do if you want just one column in a data frame, which is, we're going to get in just a second to the way that you slice like 2 or more columns out of a data frame. You just do that, only you have to put a list of column names in instead of a single column name. So if you put in a single column name, it's a series. If you put in a list of column names, it's another data frame. You would just make it a one item list if you insisted that it had to come out as a data frame. So anyway, with just this df call name, our result is a series. It's just a single list of things. So we could, all series have a .unique function that sort of comes out of the end of them, like a tail. And so we could just call that, and then we could put that inside of list, because the output from unique is sort of a weird kind of data type. But you can put list around anything list-like, and it will turn it into a plain old list, which is nice, because when you do that, I will pull this up and get it running. It's going to yell at me because it doesn't like, yeah, but it doesn't like Internet Explorer. All right, so I'll get that running, and I'll show you some of these in a moment. You can also just take any sort of series and add a .to CSV and specify where on your hard drive you want to put that CSV file. There's also a to Excel, and then you can do a .xls file. There is something that I find really handy. It's called index equals false. All those little row IDs, they're going to come out as your first column unless you say index equals false. And then you'll just want to, with series, you may sometimes need to make sure that header equals true, because I think by default it's off. And so if you put a series to CSV without saying header equals true, you might not actually get a label at the top. But yeah, just there isn't necessarily a reason to do a one column data frame, because they both have to CSV. If all you need to do is dump it to a CSV or an Excel file, you can do it either way. I don't know why I put call name unique after putting that inside of other stuff, but hopefully I have them both in there. So if I go up to the top, there is what just pulling our series out looks like. That's our print df4 program registered for. And then if we just do the .unique, we get, see it's in brackets, but it doesn't actually have any commas. If we surround it in list, we would get commas. Sorted also produces a list. And so that's a way we can sort our data and get commas, which is really nice if you just want to copy it to Notepad and paste it into something. This sorted key, this key equals str.lower parameter. It could be str.lower or str.upper. That just means case insensitive. If you leave that out, it will be a case sensitive sort when you surround something in sorted. And we can also, we put length around the entire table before to count how many rows are in it, but this is how many unique values are in it. So if we put length around df4, we can see that there are 6 rows in our original table. But if we put length around df4 program registered for .unique, we can count that there are just 4 unique values in that column. What else do we have? We can set the value of columns. So I'm going to say df4.lastname equals df4.lastname.str.upper. If you're not familiar with programming, a classic thing that is taught in every programming 101 class is that you can say code that says x equals x plus 1. You cannot write that on your math teacher's chalkboard, but you can write it in your computer programming chalkboard. And what it means is compute what x used to be, add 1 to it, and now overwrite x with that new value. And so it's the same thing. We sort of read right to left with these equal statements. We're going to say take the series that is the slice of last names and uppercase it using its uppercase function. This is what I said, that series have certain things that they just presume you might want to do that lists don't necessarily have. Well, uppercasing is one of them. And so this .str.upper, that's a function attached to every series as long as it's full of text. And the result of doing that is a new series, but where everybody's name is uppercased. And then we're just going to like overwrite the contents of last name with that. And so now you have, if we print it out, you can see that we have do, dill, dill, and jag all in uppercase. We're going to add some extra new lines. We're going to say that a new column called constant is hello all the way down. And so, and then we're going to say that we want an empty column. Sorry, this is the wrapping thing I was talking about. I should have set the screen wider before I ran it. I'll see if I can run it again quickly. But we're going to set an empty call to be full of empty cells. Sometimes you'll see NaN, not a number. Sometimes you'll see none. Either way, when you do 2 CSV or 2 Excel, they'll turn out blank. So it kind of doesn't matter, and they both respond equally well to is null. So it's just a visual thing to get used to, and just keep in mind that that means it's an empty cell. And so we're going to add a column, but fill it down as empty. And then we'll add another one where we'll add a column, and we'll grab the first this first name.str bracket O plus dot plus and a space, and then the last name column, so you can concatenate columns to each other really easily. And so we can make something called long name and put people's full name in there. And so that is what that's what we look like now. And we can also, again, we can lowercase. Now we can also then go and lowercase the first names. And what I want to show you is that even after, I went way too far, sorry. But even after lowercasing the first names, if we just show off those, you can see that that didn't automatically lowercase the J. That's something that we sort of pasted and filled down. It's not like Excel formulas where if you change the data later, it's going to catch up. It was a one-off deal. Yeah. It is changing the underlying base data, and so it's really subtle what in Python, it's pretty subtle what actually changes the underlying base data and what just gives you a copy of your base data with the data changed but doesn't actually change your original. Well, so it's more of a matter of the people who wrote Pandas wanted to make it fast to type at the expense of being simple for beginners to actually understand what's going on. So there are certain things where, like, if you say data frame df.drop columns equals, and then you give it a list of columns, that's a copy that is minus those columns and does not actually change the contents of df unless you overwrite df with that explicitly. On the other hand, when you say df last name equals blah, 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 it does actually change the contents of df. And I think they were just trying to make it simple to type based on what people usually want to do, but it does make it complicated to remember which one does which. So that actually comes to something I want to mention, which is please, please, please never export with 2 CSV or 2 Excel to the same file that you read in from. Because all of this stuff that we're seeing today, this is all just working with an in-memory, like a computer copy of your original file that lives inside of Python. And as long as you don't actually save over your original file, but you save to output file.csv, all you have to do is run your program again, and you can say, well, that code didn't do what I thought it would, and you just start over. So please be careful. Don't override your input files. Oh, there might be I may have linked at stthomas.edu/sfpy 101 recap. Yeah. You said that there were, like, what commands? I want to just make a note kind of separate in my brain what type of commands. They all kind of. Oh, the only things that'll change your file are things that are explicitly made for writing to files on disk, like .2_CSV. So unless you're using that part. Yeah, if you're just working with the file. Exactly. Great. You're welcome. All right, so I had a quick, somebody just asked real quick why it keeps running. I think we covered why it keeps taking a while to run the code. It's every time you open a new repl.it, it's firing up a server for you. Yeah, so I think we covered those. If we want to grab a whole subtable from a table, Like we want to grab the first name and the last name. It looks a lot like what we did before. We put the name of the table, and then we put little square brackets, and then what we put inside is a list of column names. And we know it's a list because it's got square brackets. So that's not confusing at all, right? We've got like our square brackets that mean grab this thing or edit this thing, depending on which side of the equals they're on. And then we've got our square brackets that have to do with lists. So it's square bracket madness. It's confusing when you're new, but so is VLOOKUP, and you can always just Google it and play around with it. Yeah, for the whole thing that I've got in blue here. So if you put this entire thing with the square brackets in a variable called myList, then you would only see one pair of square brackets in your code, just the outermost square brackets. So this is where I was saying, if for some reason you wanted a data frame, but that only had the first name column in it, what you would do is just this comma last name, you would chop that off, but you'd still have double square brackets. And that would, because inside your outer square brackets is technically a list, it's a one-item list, but it is a list. That's how you would get a data frame that just has one column. So you don't have to actually open the file again. It's just sort of, I shoved everything all together. Again, you can also write those out to CSV. The default when you're writing a data frame to CSV is to include the header, so you don't have to say header equals true, but the whole index equals false, so you don't get the row IDs as the first column, unless you actually want that, is nice. And then a cool thing that we did not necessarily see before, this thing in step 2, it's a Python thing that there's this phrase that people will say Pythonic. It means the way Python programmers love to write their code. And it's something called a list comprehension. And it's just a for loop. And so the way you read it is you start at the for, and you read through whatever comes after in, like the first thing that comes after in. And you imagine, and if you've ever written a for loop, if you haven't, this won't really help, but if you have, it's like you say for this in that, colon, and then you jump to like a new line. Maybe you put some brackets or whatever. And then there might be an if at the end. That's the next thing. Then you would say if this, colon, or brackets or whatever. And then you jump to a new line and maybe indent again. And then this thing right at the beginning before the for, that's actually what we're going to try to do. And what this, and so when you put the square brackets around that syntax, that means give me a new list where each of the members is this thing to the left of the for. So all I'm doing here is I'm taking df4.columns, which is kind of list-like. It's a name of columns in our spreadsheet. And I'm saying, just make me a list of everything in there. That's why it's just, for each item here, just give me the item itself. Don't do anything special to it, just give it to me again. But don't bother unless name is in the contents of this word that's currently being represented by X. Any questions about that? Okay, so it's kind of just Python programmers' fastest way to type building a list full of stuff from another list. And so what we just did was we just grabbed a list of all of the columns in our spreadsheet that had the word name in it. And you would think it might have been if x.contains name, but it just works differently for different stuff. With series, you'll often see .str.contains. With native Python, which is more what this is, you'll see if the word is in another word. You can Google it. You'll find it. So let's take a quick look at what that does. Let's see, where did we put those? There it is. We got our name columns. And I'm going to scroll up and show you. Here are all of the column labels with the word name in them. We have first name, last name, and long name. So that's a list of column names. What can we do with that? Yes. But what did we just talk about that we could do with that? Awesome, yes. And I have chocolate for that answer. Thank you. All right, so that's exactly what we're going to do. We're going to say, just like you asked about. You asked if we put our list into a variable, do we have to have the double brackets? No, because the inner brackets are implied inside that variable. So we set aside those names in name calls, and then we put df4, name calls, and here's what we get. We just get a copy of that data frame that we had earlier, but that only has those 3 columns. All right, so other things we can do when we start moving this syntax onto the left side of the equals. If we say data frame first last equals Kelly, we're going to turn everybody into a Kelly Kelly. That's their first name and their last name. If we say first last equals John Smith, and we make that a list of John on the left and Smith on the right, then it's going to fill everybody down as a John Smith. Now, if we tried to say John S. Smith, it would just yell at us and refuse to run because it'd be like, that's too many things. I don't know what to do with the last of those. So it does have to be either a list that's the same number as you have things here, or it has to be just a single thing. Here's a tricky one that you probably won't ever want to do, but technically you can. You can grab a copy of your data frame that is the last name followed by the first name, and then you can overwrite the contents, not the column names, the contents of first and last with exactly that. And so you can swap things. That might be useful if for some reason somebody actually has messed up the column names, but I generally recommend just actually doing a rename function because that's really weird. Yeah. Yeah, I wouldn't do it on like a billion lines without looking up some stuff about how to optimize Pandas. And I certainly would rename the columns in that case. Believe it is, yeah. Yeah. There's actually there's a big data tech conference. And I cannot remember the name of it, but there was a big data tech conference in June here in the Twin Cities. And someone did a presentation on optimizing certain repetitive stuff in very large data sets with Pandas. And they have a Medium post on it. So just talk about, just Google optimizing Pandas operations. It should come up. It was by a woman with an Eastern European name. Yeah. Mini Analytics Big Data Conference. And finally, this does not do the same thing. All this does is see how we're not actually writing to any columns on the left side of the equals, we're just overwriting the entire table. So in this case, what this does is we're taking a copy that is just the last and first names and saying, okay, the new value of DF is this much smaller table that just has those 2. Oh, and by the way, while we were at it, we swapped the order.
I'm just saying, like, in terms of a use case for like that number 5 or number 6, like say you had one user who did things wrong.
Yeah.
Right? So you could take your whole table and then you could just do that function on things that were done by that one user that did things that way.
Probably, yeah. All right, note that we didn't have anything where we could create 2 new columns at the same time and just fill it down with John Smith. If you need to create new columns, you have to do it 1 column at a time, which is, a little bit of a pain to type, maybe if you were going to put the same thing in 10 different columns, but you could Google writing for loops, and at the very least, you could put all those column names in a list, and then you could write a for loop over the list, and you could kind of only write the code once rather than copying, pasting it 10 times. But yeah, just note that you cannot create multiple columns at the same time. All right, so that's a lot of square bracket stuff. My suggestion is don't worry about whether you've got it all memorized today. You will eventually learn it if you play with it enough. And as long as you're not overwriting your files, the worst you can do is put the wrong output on your screen. Or if you've got a lot of input data, the worst thing you can do is make the code run for a minute and then you get bored and have to watch cat video. All right, so I've got video and instructions from 101. So don't get too overwhelmed. Just a few more. If you want just a copy of the data frame with only the first 2 rows, you put .head after the name, and you can even put a number in that saying how many rows you want. Otherwise, the default is 5. .tail does the last rows. If you're going to be experimenting and you don't know what things do, and it is a billion-line spreadsheet, I recommend reading it in from CSV, hitting .head, writing that out to CSV, a different CSV, and then reading that file in and playing with that data frame, and just play with that one instead until you actually have your moves down. That can actually be a really nice way to just get a small sample of whatever it is that's got a billion rows. Yeah. There are, but they're weird, and I didn't feel like putting them in here. But yes, remind me after class, and I'll.
If you know the indexes, you could do like the sum list with the.
Yes, I think it's just that it's got this thing. It's like iLoc or something like that. There's a couple of. It's not quite the same as the list thing. It's very similar, but it's just a little bit weirder, and I didn't bother to throw it in. But yes, very much so. You can definitely say, I want rows 33, 36, and 50,000,001. Same thing with a series. They've got head and tail. And then lists. These are native Python lists now. They've got this thing where you just put things in square brackets. We saw just a second ago that I grabbed an initial with that bracket 0 thing. And both lists and pieces of text, which to a computer are kind of just a list of single characters. That's actually why they're called a string, is they're like characters strung together. You'll see that thing where you can just type square brackets in a number, and that's a position number. It starts with 0 because programmers love to count from 0. :2 is its first 2 items. -2:: so think of this as like an end of the list, and that's like the other end of the list. And so the last 2 items are -2:: we did not cover any of that last time. I just wanted you to see it in case you need it. Get it in the notes so you can go back and look at it later if you ever need it. And then all those sum list things, they work with some piece of text. So you'll very, very often see Katie in text followed by bracket 0 bracket to get the letter K. Okay, last ones. We covered drop duplicates and duplicated, and we covered a little power of 1 thing. So drop duplicates comes out of a data frame and produces a copy of the data frame minus all of the rows that are considered redundant, using the columns named in column list as an indicator of what would mean redundant. If you don't put subset equals column list in, it's going to presume that you want to do it on all columns, that like if rows aren't exactly identical, they're not duplicates. This keep parameter that you can type, it's got 3 possible values: first in quotes, last in quotes, or false with a capital F. And so if you set it to false, it'll produce a copy of your data frame, keeping only it will actually drop all duplicates. So drop duplicates keep equals first will drop, it'll keep things that don't even have a duplicate, and it'll keep the first thing of things that do have a duplicate. Keep equals false will literally just only keep things that never had a duplicate in the first place.
Can you think of what is that subset equals column list? What is that function?
That's what you asked me about earlier, where can you so that just said, okay, so for example, if you didn't put in a subset at all, and you had first name, last name, and email, that you had a 3-column spreadsheet, it would make sure that all 3 of those had to be a match before it considered them a duplicate. Whereas you could specify there, no, I just want to look on first name and last name. And if somebody's just a match on first and last name, even if they've got different email addresses, they're a duplicate, and I want to drop the redundant ones, or I want to drop all of them. That's what that means. Good question.
Column list is a variable substituting for the names of the headers of those columns.
Yes, sorry about that. I'll do that a lot in these slides, so thank you for clarifying that. Yeah, when I say column list, that's implying that it's a variable. And then has a dup TF series. I like to just, it's sort of like I do the DF thing when something is a data frame. In instructional stuff, I like to put the word series at the end of a variable where I'm keeping a series. So when you take a data frame and you do dot duplicated, and again, you can specify a little bit of granularity on what exactly qualifies as a duplicate. This is a little weird because keep equals false. What this does is this produces a series that's just full of true and false values. And it has the same item IDs that your data frame had row IDs, but it's full of answers about whether those rows were duplicated or not. And similarly, keep equals, so if you do that with keep equals first, if the row never even had a duplicate, the answer will be false. If the row had a duplicate but was the first one seen, the answer will be false. Finally, if the row had a duplicate and was not the first of the dupe set, then it will be true. Duplicated with keep equals false will mark things as true if they even have it, whether they're first or the fifth or whatever, if they have a duplicate, if they have a sibling, then they get the little true flag, which is why it's kind of weird that you type false to find out what's truly a duplicate. That's what you do, though. And then things that were special snowflakes will be marked false because what you're checking is it duplicated? And no, they weren't. So a neat thing, one thing that you may have noticed is we could keep things that were special snowflakes plus the first of every duplicate set in our first one. We could deduplicate something, basically. Or we could find things that were never duplicates in the first place. But what if we have a million rows and we're pretty sure that only maybe 3 of them might be duplicated, and we want to just see the redundant data? So if you want to keep all rows that are a duplicate in some way, first you have to create one of this has a dupe series, and then you pass it in between brackets. So here we go, yet another df bracket ... And if you put a different thing inside the brackets, it does yet a different thing. So we've put a single column name inside of brackets. We've put a list of column names inside of brackets. Here's a third thing we're going to do. We're going to put a series that has the same item IDs, but df has row IDs, and is full of true-false values inside those brackets. And when you do that, it produces a copy of your data frame with only the rows where that series said true. So that, putting number 3 and number 5 together, is how you would actually get a list of duplicates. Questions about that? Okay, awesome. And then finally, these two things, they're just a bunch of trues and falses. And trues and falses count as ones and zeros. And anytime you want to know how many things are true in a list of trues and falses, just add them up, because it'll be the sum of all the things that are 1. And so now we can say there are this many duplicated rows in this many groups. And so if we're just looking at is it a first of a dupe set? Well, the number of first is going to be the number of dupe sets, and then the total number found across those dupe sets is going to be the sum of all those. So power of 1 trick. That was a lot. Questions? You get a break after this. So seriously, questions?
Are those slides up somewhere?
They are, actually. Yeah, I'll put a link up to the slides when we go on break. Yeah. Yeah, let's see, where do we go? We had hello, we had info, hello, files, and 101 recap. Actually, I'll put that in the. Okay, I don't see any questions in the chat room, so we can go on break. It's 12:45. We can be back at 12:55, and if anybody wants to stop playing Fast and Dangerous where their car's parked, that'd be a good time. link.stthomas.edu/sfpyinfo. And then near the top, I think I put the slides in. Let me see if I actually was smart enough to do that. Depends on how it's marked. Where'd you park? Did you see any signs saying Selby and what? Selby alongside, like were you on the houses side of the street or the St. Thomas side of the street? You're fine. As long as our campus is next to, Yeah. Because it's permit only on the houses side of the street. All right, guys, now can you hear me? Okay, sorry about that. I went to the bathroom over break and I unplugged my lav mic at the waist. So the computer was recording, but I was not. All right, so just real quick, what I said, a lot of this is on the screen, but what I said was just that these two as written do the same thing as each other. It's just that the main reason you would ever do number 2 is if you want to take the part only to the right-hand side of the equals in number 2 and just use it as a throwaway thing. If you don't actually want to update the contents of the data frame, then you can make a copy of the data frame, pass it to some other thing, and there it is. So that's the main reason I would ever use 2. It's longer to write, so I don't really do it. Welcome back. Yeah, you didn't miss much because I had to repeat it all for the online because I had unplugged my mic. But we're just talking about adding, removing, renaming, and reordering columns. There's 2 ways to add a column. One we've already seen. You just type the column name and say what you want it to be, and it'll magically add it to your table. You put it on the left side of an equals. The other one is there is this thing, you can take this, you can say .assign and start typing column names as long as they don't have spaces. You can do more than one column at a time that way. It will get thrown away unless you then overwrite the original data frame. Because what this produces, this .assign, it produces a copy of your data frame. Then you have to overwrite the old data frame with that. Whereas this other one where you say data frame bracket column name, that automatically knows, actually please overwrite the original data frame. All right, deleting a column. We got 2 ways to do it. The first one, let's see, this is if you only want to keep a couple of columns, you just name what you want to keep. It's not even quite deleting. It's really more, what you're doing is this is a copy of a data frame. We did this earlier when we generated a list of column names. We said last name, first name, and long name, and then we printed just those 3. We put them in, we selected just those 3. So on the right is a copy of your data frame that only has those 3 columns. If you overwrite the variable that is containing your data frame with the new copy, ta-da, you've thrown away your old data frame and you've replaced it with the copy. And so it's as if you had deleted everything but those columns. Yeah. You could, because they're all going to be surrounded by quotes. It's just that one weird assign thing. In all of these, you can have you can have lots of you can have spaces in the column names. It's just that one where it makes you take the quotes off. Well, then now you can't actually use anything with spaces. Does that make sense? Okay. And then similarly, so this other thing on the right in number 2, that's also just a copy of your data frame, only that's a copy minus anything you explicitly named. And again, if you want to save it, you're going to need to overwrite the original. You can either save it to a new variable name, maybe you want it in its own separate variable, or you could just overwrite the original with it. The nice thing about both of those is if you don't actually need, if you just temporarily need a copy to pass to something else, either one of those, you can do it. It really, whichever one is faster to type depends on whether you're keeping more columns or dropping more columns. Reordering, really there's only one way to do it, and it's the first one we just saw for dropping. The only thing is if you want to keep all of the columns, what you need to do is you need to explicitly name everything that was in your data frame. So if you have 10 columns and you want to keep all 10 just in a different order, don't forget to actually type all 10. So you're just going to type a list of column names in a new order, and then you're going to potentially save it over your original. And there's really no good reason data-wise usually to reorder your columns. That's just a thing you do to make things pretty when you finally dump it out to a new file, or when you're just exploring your data and printing the first few lines, and maybe it's doing a little ... in between because it's a 200 column spreadsheet, and so you just want the things you actually want to look at in like columns number 1 and 2. And finally, there's just one way to rename columns. It's data frame dot rename, and then you say columns equals, and before, let's see, with the drop it was still columns equals, but it was a list there. This is a new thing that we've got. This thing in the curly braces, it's called a dict. It's a dictionary. It's called a map in some languages. Hash map you might have heard. And what it just means is this is equivalent to that. So the colon means is equivalent to. And then the comma means, okay, I got another one. this is equivalent to that. And so it's like a direct, the colon can be thought of as like a little arrow flowing into the second one. And then the commas are just separating them. And the brackets means that it's not a list. It's one of these things where it's going to, you know, in between each comma, there should be two things, not one thing, because they're a pair that goes from left to right. And so anything, if it finds column name 1, it will rename it new column name 1. And if it finds column name 2, it'll rename it new column name 2. And it'll leave all the other column names alone. And then again, that's just a copy. So sometimes if you just wanted to pass a copy to something, which you might actually do for merges, you might just, because when we connect tables, Python likes to connect them based on what the column names are. So if you have first name in one spreadsheet and you have the word first in another spreadsheet, or the capitalization is off, you might want, you know, there are different ways to handle it, but you might want to just tweak the column names in the second spreadsheet to be more in the style of the first spreadsheet before you try to put them together. So that's a time when you might just sort of throw away rename. You don't actually need to rename your original data, but maybe you want to have a copy of it where things are renamed that you pass into a combination of two spreadsheets. All right, so let's open up SFPY 123. Yeah. That's true. Yeah, you got a point. I don't think we deal with a lot of that in Salesforce land, but you're right that if you're doing it from Salesforce to something else, that might be very important. Yeah. But renaming is very handy because data loader likes to export things in all caps. And I don't know if anybody's ever done developer workbench, but that likes to do things more with their normal camel casing that you actually typed things with. And so if you're trying to put two tables together, one that you dumped from one system and another you dumped from another system, it can be very handy. That list comprehension thing that I did, I think I may actually have it as the door prize script. I've got one. Let me just see real quick. Yeah, I've got it. Yes, I have door prize scripts. Those are things that we don't really go into very much, but you can take them home and poke at them at your leisure, and they might be handy in the real world. Yeah. So I'm going to show you how to generate dynamically that thing where I typed column 1 becomes new column 1 and column 2 becomes new column 2, how you can go over a list and use that to produce one of those by computer. And that can be really handy for, say, uppercasing everything to match the other one. So, all right, so how are we doing on, let's see, has anybody not gotten this output yet? We're gonna make sure everybody has it because it's really important for our next stuff. Okay, just real quick, because I wanna make sure nobody's shy. Raise your hand if you've already gotten this output exactly like it looks on my screen. Oh yeah, sorry. So, all right, let me pull this up. We're going to add a column called hello with the phrase yay us filled in all the way down. We're going to modify df1 by adding a new column. And we're just like we made everybody a Kelly, we're going to make hello every single row with a yay us. Next, we're going to rename last to last name, and we're going to rename first to first name, just like we renamed column 1 to new column 1 and column 2 to new column 2. Third, we're going to delete. There's a column in our original spreadsheet called email. We're just going to get rid of it. And finally, we're going to reorder things so that they display in this order: hello, last name, company, first name, ID. So I'll pull that up together. I'll pull that up as well, and we can do it together if anybody wants to see us do it. All right, so what would people think about how we might add the yay us? Okay, so what's something you might do? What should I type here? df1 Anybody got it? Okay. I should show on the SFPY info under exercise 3. I have one that says cheat sheet. And if you jump there, it's right below the exercise. I've got our code. I don't know if that'll help. So does anybody have a suggestion of what maybe I should type looking at this to add hello and yay us? All right, DF1. And then
Square bracket.
awesome. And what do I want inside the square brackets? Quote, hello, quote. Thanks for remembering the quotes. All right, now what? All right, and I'm going to print a copy of DF1. This is a really handy technique before you get too deep into stuff, is you can just see what it looks like partway through. See what we've got so far. So there we go. We've added a hello, yay us. Good for us. Yay us. All right, let's add another line. We're going to rename last name to last name and first to first name. If I go over here and we look at the renaming approaches. This is very hard to all get on the screen. Yeah.
So like if you're working with a really large data frame, you can print the entire thing, like all those rows.
It'll put some dots in horizontally and vertically. Okay. Yeah, good question. It'll print a lot though. All right, so anybody in here want to help? Want to start chat? You can do so too. Anybody have any ideas to start me off here? Yeah, sorry. It's so hard to keep everything on the screen all at once. I do not know how to. I think if I zoom in, view, zoom, 200%. Now I should be able to scroll a little bit. All right, so we are now renaming. Yeah. So, any ideas what I should type? Okay.
And then curly brackets. Quote, best, space, name.
Sorry. I guess it depends. Right now, our data. Why is it ugly? Right now, our data has a last column. Okay. What would you suggest instead?
Close quote, then colon.
Uh-huh.
And what did we want to rename it to?
Last name.
Okay, then open quote, last space name.
Comma. All right. Now what? First, colon, first name. All right, let's see if it works. Probably. Some of them you do, some of them you don't. Let's see what happens when we run it. Nope, it did not do anything. So let's add columns equals. Easiest way to find out if something works is to try it. All right, now we have first name and last name. All right, so we're halfway through. Why are we? Because we need to. In this case, we don't need a list of things. We need a list of definitions. So it's a dictionary. The curly brackets implies it's a mapping. So it's last. You think of the colon as like a rightward spacing arrow, and it's like last becomes last name, comma, first becomes first name. Yeah, good question. All right. So next thing that we want to do is get rid of the email column. I'm going to pull up our dropping columns. We got sort of. We could, yes. Because what are our two ways that we can drop columns? What are the two things that we can just keep what you actually want? What's the other way? Well, what's the other way to get rid of stuff? Get rid of the ones you don't want. Okay, and you're saying take the keep the ones you want approach, and since it happens to keep things in the order you type them, just combine that with the reordering. All right, let's do that. So if we look at the reordering approach, we're going to let's see, I gotta get this showing stuff. All right, so there's our reordering. Tell me what to type. And oh, can I actually get these all on the page? Come on. This is gonna be hard, guys. I wish these had bigger screens. All right. I got it. I don't have the other one now. Okay, df1 equals. Uh-huh. 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 And then let's what else? All right. What do you think? I think you might be right. Shall we run it and see what happens if we don't? All right, we get an error saying that it can't find a column called hello, comma, last name, comma, company, comma, first name, comma, ID. Exactly. All right. So we're going to read the first column. 1, 2, 3. Yay, yes. All right. Good job, guys. All right. So that's what we did. I had taken in the sample, I had taken the approach of first dropping the one I didn't want and then reordering it. But I like the idea that you guys came up with of saying, why bother? We're about to select a list anyway. We just won't mention email while we're at it. Any questions from anybody here or in the chat room about what we just did? Yeah. The code that we came up with? Correct. We overwrote df1. If we had wanted to do it differently, if we had wanted to keep df1 the way it was for later reference, we might have called it df1b and said that it was equal to df1.rename. And then from then on, we would have said that we were taking df1b and overwriting df1b. Yeah, I mean, if we wanted each of these, we could have said df1c equals, or is. But if we didn't care about saving out each and every intermediate step, we wouldn't have had to come up with a new variable name each time, just the first time. So depends on how much data we actually want to set aside versus how much we're comfortable throwing away because we didn't actually need the intermediate step. Sometimes I also make that decision based on readability for my future self. All right. Any other questions?
As you execute, things go wrong sometimes.
Yeah. Another reason I do it is, yeah, I mean, you can put a comment on a line saying this does this, you know, rename's kind of obvious, but if it weren't obvious, you might put a comment there. Another thing you can do is just save it off into a variable name called thing I did that's full of this now. Oh, good question. For comments, anything that starts with a pound is a single line comment. Anything that is between two triple quotes is a multi-line comment. Actually, what it is it's a multi-line text string. But because everything gets thrown away that isn't actually put somewhere, you're literally just like typing hello world and throwing it away. As opposed to the single line pound things are actual comments, and they also can, like single line comments in many other languages, be typed at the end of a phrase. All right, so moving on, we're going to real quick take a look at this door prize script. It's in the table of contents under exercise 3 for your SF in your SFPY info. But basically, what it does is I've got this list of people. We saw the registration log earlier, but now I've done a pivot on it already. I'm not going to explain how I did it, but I've done it. And so now what I have is I took like all the people and I took what they had signed up for and I put the word program before it. And if they had registered for it, I put the word registered in the intersection of their name and that program. I've got a whole other piece of code that actually did that, but I've already done it. Well, let's say now I've decided that, you know what, I want to rename those. I don't like the word program being before all of those. So what I could do is I could say that we saw the list generator earlier. So I can say columns with program in the name equals open bracket, close bracket. And then I have my whole like X, which just means just give me a copy of whatever is currently in the loop. And then loop through each item of df.columns. I don't know if we looked at df.columns, but it generates a kind of list-like thing that is a column list. And sometimes actually that's really handy because literally you've got a 200 column spreadsheet and all you want to know is like maybe you just want the columns in alphabetical order. So that can be really handy. You can put you can put sorted, you can put print, open parentheses sorted, open parentheses df.columns, close parenth, and boom, there's your comma separated list of alphabetized column headers that you can then go tell your boss about or whatever. So anyway, we're going to loop through all of the column headers, and then we're going to say, but skip over that item unless the word program is in the column header, and we're going to take everything that remains that is in this new list we just built, and we're going to call it columns with program in the name. Then we're going to do it again, and we're going to loop over columns, and we're going to say only throw it in this list if X is not a member of the columns with program in the name list. And we're going to call that the rest of the columns. Everybody following this so far? Awesome. You guys are so good. You're so Pythonic because you're following list comprehensions, which is like a really big deal. All right, so then there's this cool thing you can do to append one list to another, which is you just put a plus in between them, just like you would with text. And it just builds one list where it goes if you have A, B, C, D, E, and the other list has F, G, H, I, you just get a list of A, B, C, D, E, F, G, H, I. So we're going to say new column order equals columns with program in the name plus the rest of the columns, which is how we're coming out with these now at the left. And so we're going to reorder things. There's our df equals df bracket new column order. Then what we want to do is we want to do a rename. But before we do the rename, we're going to do something kind of like this list comprehension, but it's called a dict comprehension. Instead of getting a list as output, we get one of those this thing colon that thing lists called a dict. And so instead of a bracket, we're going to put curly braces on either side of that for loop. And we have to have two things to the left of the for. One thing and then a colon and then the other thing that it goes with, because that's how we do these things. And so what we'll say is the first item should just be the thing that we're looking at in the for loop. It should just be the column name that we're looping over. Colon, the second name should be that thing, but if you see the word program, replace it with blank text. So cut text out of it. So that thing, colon, the same thing minus the word program. And we're going to do that loop over columns with program in the name. And so that's how we dynamically, we hand typed first colon first name, last colon last name before, but we can get the computer to do that job for us if we have a pattern that it's going to follow. And so then we're going to do the same thing. df equals df.rename columns equals, and then anything it finds that matches that pattern, it's going to rename. Everything else it's going to leave alone. So that's how we ended up with acrobatics. It no longer has program before it. It's just plain acrobatics. Basket weaving, computer Ming. Okay. Turns out that it was computer programming with a capital P. So just because you can do it in code doesn't mean it's going to do exactly what you thought you were programming. But that's true in anything, when you do a Salesforce formula field, when you do Excel, and scuba diving. And then we have the rest of the columns at the end. So any questions about that? Yeah. Correct. Right. Yeah, this was a little bit more readable, but again, the more you get used to it, the less you can focus on readability, and the more you can just focus on getting the job done. It's true. Although in this case, yes, so I would still want the for X in, I would still at least want it to be a list of column names, like df columns. I wouldn't want it to be df. I would at least want it to be a list or a sublist of the column headers. Yes. Yeah, and honestly, the replace thing doesn't even care which order they go in. So I could have just used df columns even after I had already reordered things.
Well, and if you were able to anticipate that computer programming issue,
Yeah.
you maybe could have instead found them where you use different code where it starts with program.
Yeah. And there's also something there. Yeah, there's fancier versions of replace. There's something called regular expressions, which are like an entire programming language to themselves and really hard to learn, but they can help you with stuff like that. So there are a lot of ways you could have done it. Yeah. So yeah, that's how it is. All right, so we're finally going to start combining some spreadsheets now that we have some fundamentals down. All right, so you really need to, when you're thinking about combining spreadsheets, think about whether you want to stack them on top of each other or put them to the left and to the right of each other. They're different, and they have different Python commands. And one thing that's nice is that the vertical one starts with a C, and if you're writing the capital letter C, you start at the top and you move to the bottom, and that's the one that does vertical. And the other one starts with an M, and it goes left to right. And if you draw a capital M, you start at the left and you go to the right. So that's how you can remember that. But for vertical, it's when in Excel you would be copying a spreadsheet or a column and pasting it below another one. And it kind of can, it can be just two, but it can also sort of be infinity. There's no real like end to, you know, just copying and pasting over and over and over again below stuff. And so that's the concat. It's and it's a little bit different. Sorry, I've got it way at the bottom here, but pandas.concat, and then you give a list of data frames or series that you want to combine. And then the other one is more like a VLOOKUP or like an access when you build join relationships, or it's more like if you're a database programmer, it's an SQL join. This is the sideways thing. And you can only do two at a time because you're only specifying this thing on the left is equivalent to this thing on the right. You're actually using columns to say what's equivalent to what. And so you can only do two at a time, although after you finish that, you can certainly do that to yet another one, and yet another one, and yet another one. But unlike this one where you can pass in a list 100 spreadsheets long, this one you've got to do 2 spreadsheets at a time, the sideways one. In the code for that, you pass in a single data frame, then you say dot merge, and you pass in another data frame's name, and then there's a bazillion, they're called parameters. They're settings that you have to specify, like which columns are you saying are equivalent to each other, and what type of merge do you want to do? Because you actually have a lot more power with that than you do with VLOOKUP. But that's the gist of it. So there are not. It's a lot more like a traditional database join. If you have, if you have three people, if you have 3 rows in table 1 and you have 3 rows in table 2 and you're joining on first name, and this is the horizontal merge. If you're joining on first name and you have like Amanda, Barry, and Claude in table 1, and then you have Barry, Claude, and Dave in table 2. Actually, sorry, if you have Barry, Claude, and Dave in table 2, then your output of that will, if you're doing a horizontal merge, you will have 1 row for Amanda that is like empty at the right side because she wasn't even in the second spreadsheet. You'll have 1 row for Barry because he only appeared 1 time in each one, but like on the left will be the stuff from the first spreadsheet, and on the right will be the stuff from the spreadsheet. Actually, I'm going to say that Claude appeared twice in each spreadsheet just to really sort of help you. It was like Claude loves apples, Claude loves bananas in the first spreadsheet, okay? Each on their own line. And then in the second spreadsheet, it was Claude has a Volvo, Claude has a Subaru on separate lines. You're going to get 4 rows of output when you put those together in some configurations. You could get up to 4 rows of output because it would be Claude, the Volvo driving apple lover, Claude, the Volvo driving banana lover, Claude, the Subaru driving apple lover, and Claude, the Subaru driving banana lover. You'll end up getting 4 rows of Claude potentially. And then you would have Dave's line, which would be blank left. So questions about how that comes together, you've seen it before if you've done it in Access or in other databases. It's a little new if you've just done Salesforce or VLOOKUP. Okay. All right, so first of all, the kinds of business problems that we might have as a vertical business problem. We've got just listing all the unique email addresses in a spreadsheet. Like, maybe we want like the ones that were in email, the ones that were in work email, or the ones that were in school email. So I'm going to pull up that example. So we've got Annie Appleton, Andrew Appleton, and Bernice Bonita. And sorry, just those 3. And we've got those, and then we've got email addresses for them. And Annie and Andrew are married and they're sharing a main email. So they've just both got aa@example.com. And so as output, what we want is just every unique email address found in our spreadsheet. So we want aa@example.com to just appear once. And then we've got bb@example.com. And we've got them all, everything we found in the spreadsheet in those 3 columns, but just stacked in one nice, neat little thing. So if we were in Excel, we would cut the work email column and paste it below the email column. And then we would cut the school email column and paste it below that. And then we might rename the column from email to emails. Does that make sense? So business-wise, that's what we're doing. Another business problem we can do is the same thing, only with 2 spreadsheets. Because if we had 2 spreadsheets, this one, and then a second spreadsheet where we had 4 more email addresses on file, email adder, email 2C, email 3C, and email 4C for Bernice. We don't actually, most of them aren't even unique. They're the same ones that we had in the other spreadsheet, but we did get a new one. We got bb@play.com. So now our output also has that at the bottom. So again, if we were in Excel, we've just got 4 more columns to paste at the bottom before we do our final rename to emails. But it's kind of the same business problem, just the source is a little bit different. Let's see. So if you guys want to see how that works, let me make this a little bigger. So for that first problem, I said that pandas, I would say pandas.concat, parentheses, And then here's my little list indicator, and here are my commas in between items. And lists don't care if there are spaces after your commas or not, so it's up to you for readability. And I said DF email, which is a series. That's just grabbing the column, the email column. And then my next thing that I passed was another series, the work email column. And then the third thing that I passed was the school email column. In this case, and actually, sorry, I take it back. That doesn't inherently make things unique. It leaves if we had blanks in there, it would have left them in there. If we had duplicates like the AA example, they would have appeared on their own separate lines. It's literally just the copy paste part. I personally wanted to get rid of the blanks and get rid of the duplicates, so all series come with a drop NA function that just drops all the items that are blank.
Can I throw in that if you are using the data loader, and you have some kind of rows,
Yeah.
where they're like you can't see anything, the data loader is supposed to see that and they'll punch out without error. Yeah.
Oh, interesting.
Like it seems it's not null.
Okay, so you're saying you can see a reason to do this to just make sure there aren't ghost rows in your spreadsheet.
Yeah, before you go into the
Yeah. What? Ghost rows? Yeah. So then I'm going to save that out into its own variable for readability. You sort of talked about like, what if you want to save everything you do as its own variable name? That's kind of what I'm doing here. And so then I'm going to take that, and all series also have a .unique function. We saw that earlier. And that does not actually produce another series. It produces a thing called an ND array. It's part of a different package called NumPy that Pandas sometimes output comes. This is one of those things where I said like, hey, if you get something weird and you don't know how to work with it, put type around it and see what comes up and then Google that. That was how I found that out. So anyway, I called this _ND array to remind myself that it's not a series, even though it's also, it's not a series, it's not a list, it's another thing that's kind of linear that I'm going to have to Google. So because it does not have a .toCSV function, I then Googled, how do I get it back into a series? Turns out that the way to do that is you say pandas.series parentheses, and then you put this list-like thing as your first thing inside the parentheses. And then I also wanted to just make sure that it came out with the word emails at the top, so I gave it a name. And then I didn't even bother to save it into a variable. I just immediately started up with my .toCSV, which is a neat thing you can do, but also a little hard to read sometimes. And I wrote it out to the file, and that's how I end up with a CSV file that has one column and looks like that. Questions about what I did? Okay. So example 2 is the same thing, but I just typed more stuff in the list on the first line. It's literally otherwise exactly the same, but you can see after I get to the end of DF1 school email, I pick up with DF2 email adder. Literally just like in Excel, you would just, after you're finished cutting and pasting things from your first spreadsheet, you would go over and start cutting from your second spreadsheet. That's all I'm doing here. All right, so another business problem that's a little different is, let's say we had first name, last name, and email in spreadsheet 1. And then we had first last email. Then we had last name, EM, and first name. We know they're the same idea. We want to concatenate them appropriately. And so it's pretty much the same thing as we were doing earlier, but we got to get we need to get a little more clever. Turns out that, so I should mention that when you're concatenating series, they throw them all one under the other. I think the header stays the same as the first one in the list. When you're concatenating entire data frames, entire tables, it will try to throw data with the same name underneath where it already found other data with the same name. And then it will just start up a new column to the right if it hasn't seen that column name before. Does that make sense? So if we just plain old concatenated these two, because they don't have the same names, we would literally get this second one starting at the bottom. We would have a 6-column spreadsheet where the whole upper right-hand corner was blank and the whole lower left-hand corner was blank. And that's not what we really, really meant to do. That's not actually very useful, right? So what we want it to look like is more like all those people, but we'll keep the column names and the column order from the first one, but we need our program to understand that actually that EM is the same idea as email. So where did I go with the code? That's up above, sorry. So first thing I'm going to do is I'm going to define a dict of what's equivalent to what. So I'm going to say column 2 is equivalent in column 1. So first name from column 2 is equivalent to first from column 1. Last name is equivalent to last. EM is equivalent to email. Then I'm going to say that I want to concatenate df1 and a renamed copy of df2, where I renamed things to match df1. So that thing where I said that you can take the rename and you don't actually need to save it out to a new variable or replace the contents of df2. Sometimes you just need it temporarily to pass to another thing. This is an example of that. We just took a renamed copy of df2 and we threw it into this pandas.concat, and we're saying, please concatenate df1 and the properly named copy of df2. The same names. Otherwise, it will concatenate, but it'll shove them off to the side as brand new columns. Yeah. And then sort equals false is this weird thing. They're going to change it one day, but right now, pandas.concat rearranges all of your columns to come out in alphabetical order for no apparent reason. So if you don't want them in alphabetical order, if you actually wanted them more like, no, the columns that I found in the first one, and then any extra columns you found in the second one, and then, in more the order you put them in, you have to add comma sort equals false. Just a quirk. They're going to get rid of it and make it do what you would think it would do later. Then in this particular, now this again, it's just the copy paste part. It's not getting rid of any duplicates. But I personally think, well, why bother to have the duplicates? So I'm going to call the .drop duplicates command on this. And with that subset thing where I could say, I don't, do I want this to be on the whole table? Do I want it to just be on certain columns? In this case, it wouldn't really matter because the columns that are in df1 are the same as the whole table, so I could actually leave this blank, but I wanted to show you can specify, in case, maybe in this thing maybe in the second file we had like a 2-column spreadsheet, and we wanted people to show up, but maybe like just the second column to not be blank, if people were in the second one, but leave it blank since there was no such column in the first one. So it's still going to stack them, but maybe we actually wanted that, the whole table stacked. So that's why it can be nice to be able to specify what are we deduplicating on. So anyway, I'm just running this drop duplicates that we glossed over earlier, and I'm still kind of glossing over, and I'm going to save it off into a new variable, and then I'm going to take that new variable and dump it to CSV file, and it looks like this. So that can be kind of a nice way to get yourself like a master list out of 2 spreadsheets. And then lastly, we have 3 different Eventbrite exports, and we don't want to just dump them into the same spreadsheet the way we did here. And actually, since there are logs of people attending different events, we don't even want to deduplicate it. But what we would like to do is make sure that we don't lose track of which row came from which spreadsheet. So we want to add text. We want to add a new column to each spreadsheet called which sheet, and fill it all the way down with some value that indicates the sheet that it's in. So we're going to do the same thing. We're going to say pandas.concat, and we're going to pass it 3 different data frames: data frame 1, data frame 2, and data frame 3. Only what we're actually going to pass it is copies of those data frames where we've added a new column. This is that assign thing we saw earlier. And it's going to say data frame 1, give it a copy where it's got one extra column filled all the way down the word event 1. Pass in a copy of data frame 2 with 1 extra column filled in all the way down with the word event 2. Same with data frame 3. And then I'm going to do a little sort values. I don't think we covered sort values earlier, but it's a neat thing you can do you just take a data frame, say dot sort values, and you say by equals, and then you give it a list of columns. You can also get a list of trues and falses to say whether it's, whether each column is ascending or descending. Yeah. You're going to ask about that? Yeah. I think it's like AS, comma, ASC equals in the list, but by default, they're all true or they're all ascending. And so if our input is, we had Annie and Bernice at this event and Annie and Christina at that, at the second event, and Christina at the third event, then when we copy and paste them all down, and sort them, we're gonna get Annie at event 1 and event 2, Bernice at event 1, and Christina at event 2 and event 3. So we have a nice little master log of who came to every event. Questions?
What's the which sheet?
Oh, that was just a name I came up with that I thought would be a good column name to indicate the data source. You could get really fancy and like add a column, and like instead of calling it event 1 manually, you could like go out and Google code to like actually like parse file names and stuff, you know, and you could get pretty fancy there, but it's just a way of indicating, because in this case, I didn't have anything in the data that said what event it was. So I added something by hand. Because otherwise I would have just had people attending or not, and I would have been like, but what did they attend or not? Whereas I already know what they attended or not when they're in their own spreadsheets. So sometimes you might have a reason to add a little bit of information all the way across the board before you combine it, before it all just gets mixed up and you have no idea where it came from. Possibly, it depends. I mean, you know, if you're just going for like a master list of contacts, you might only want one copy of people anyway, and who cares where they came from? Yeah. All right, so merging. Things you might want to do. You might want to take a country code and a capital, and this is easier to show than to explain. All right, so in one table, we've got a bunch of people and where they live. In the other table, we've got a bunch of facts about countries. And in our output, what we want to have is the first table, plus we want to have some of those facts about the countries off to the side, indicating not only where they live, but what the capital of the place that they live in is. So that's a merge, and that's the one that's closest to VLOOKUP. And what that is known as in the world of databases is a left merge. There's 3 kinds of merge and 3 kinds of join, merge, whatever you want to call it, that you need to know about in the world of databases and in the world of pandas merges. One is called an inner merge, and that means that if you don't find a match, if this piece of data is not in both spreadsheets, in the columns indicated as being the matching columns, don't show it. It's not relevant. A left merge means, please reproduce my original spreadsheet that I'm putting as spreadsheet number 1. And then if you happen to find something matching in spreadsheet number 2, show me that too, that'd be great. So in the case of my example earlier with Annie, Bob, and Charlie, or whoever they were, and we had Charlie listed twice, apples and bananas. Now we would still get Charlie twice, come to think of it. Now, either way, we get Charlie twice. As long as he matches, we're going to get the same stuff. But we're not going to get Dave. Yeah. With an inner merge, we're only going to get Bob and Charlie. In a left merge, we're going to get Annie, Bob, and Charlie, and any details about them that might appear. And then in this third kind called an outer merge, we're going to get Annie, Bob, Charlie, and Dave. And there's just going to be blank spots to the right or to the left as appropriate if they weren't in the other spreadsheet. So inner merge is only show me stuff where people are in both spreadsheets. Left merge is show me everything from spreadsheet number 1 and details from spreadsheet number 2, if applicable. Outer merge is show me everything from both spreadsheets, and if they appear in both spreadsheets, stretch them out horizontally and show me the details on the left and on the right from both spreadsheets. Yeah. Yes. And usually what you do is you do an outer merge and then you do a row filter. Pandas has recently added a setting in the merge that adds one more column to your output called _merge, and its value will either be left underscore only, right underscore only, or both. In an inner merge, it's always going to be both, so there's kind of no point in turning it on. In a left merge, it's going to be left underscore only or both. And in an outer merge, it's going to be any one of those three. And you can just filter out the word both and keep only the ones that say left only or right only. And yeah, now you've got your, and that's really, really nice for like looking at a transaction log and seeing if there's anything that is not where it belongs. Yeah. So
I have a list of important things, and then I have a master list of lots of details or whatever.
yeah.
All of these important things out over here, and then there's a bunch of stuff that's
yeah, like a bunch. Like I don't care about Iceland because I don't have anybody who lives in Iceland, for example.
Right. So I want additional details that can be found here. My stuff. Which one is that?
That's left. Good question. Yeah, so to repeat for the chat room, if you have a list of important stuff, and then you have a list of as spreadsheet 1, and you have a list of details as spreadsheet 2, and you don't care about Iceland in spreadsheet 2 because you don't have anybody in spreadsheet 1 who lives in Iceland, that's a left merge. You want everybody in spreadsheet 1, and you only want details from spreadsheet 2 if they happen to also be in spreadsheet 1. And so the code we do for that, first of all, I've in my output, because we're going to get everything, including, for example, the square kilometers when we do this, I've decided I'm going to say that my columns to keep are all of the columns in my first spreadsheet plus just code in capital from the second spreadsheet. And we'll use that in a minute. Then I'm going to move on. I'm going to be a little bit scatterbrained. Now what I'm going to say is take my first spreadsheet, my spreadsheet of addresses, and dot merge. And then I'm going to say, what do I want to merge it with? I want to merge it with DF2, my Wikipedia of countries. And then I'm going to say column how equals, and then I'm going to put left in quotes, all lowercase. So that's the left merge that we were just talking about. And then I can, if my column names are matched up to each other, I just say on equals, and then I do a list of column names. If they're different from each other, I can do this thing called left on and right on, which is kind of nice. Because, see, I can just indicate, I know that it's called name in the countries table, but it's called mailing country over here. So I'm just going to say left, which I know DF is to the left of DF2 when I type this, DF1, sorry. So I know that DF1 is left. So left on mailing country, right on name. When sorry, I should have put this in a runnable example so I could show it to you. But now I'm going to save that off as a data frame called merge.df. And that's got everything. Now I'm going to overwrite merge.df with a copy of merge.df that only has these columns. Like, I don't actually care about the redundant copy of name or square kilometers. I just care about code in capital. Does that make sense? People following along? Okay. Then what I want to do is, just because I don't like code off to the, I don't feel like in my final output the word code is descriptive enough. I'm going to do a little rename just for business purposes. I'm going to say change code to country code, change capital to country capital. And then I'm going to export it to CSV. And that's how I got this information. All right. So another thing that you might want to do is you might want to take two different sets of people, such as these people and where they work, with those people and their favorite food. And you might want to combine them so that you can have, for example, you can see some of these people, we only know their favorite food. Other people, did this come out wrong? I hate it when that happens. Imagine everything one to the left in this table, sorry. Some of these people, we don't know where they work. This would be blank. This is not a problem with Pandas. This is a problem with my web editor. When I put in the data, I didn't get the spaces right. And you can see some of, these people who are in the left, we have their ID from that spreadsheet. These people who are in the right, we have their ID from that spreadsheet. And then people who weren't in one spreadsheet or the other, don't have an ID from the other spreadsheet. We have that merge thing with the indicator. So this is an outer merge, an outer join, where we, so now we know that Marilyn Monroe works for Fox and loves carrots. We know that Vandana Shiva works for Navdanya and loves amaranth. So we've been able to put people together based on matching them by their first name, last name, and email, I think. So in this case, what I did was I decided instead of doing the left on and right on, I just renamed the columns of interest to me in my second spreadsheet. So I built my little renaming map. And then I said df1 dot merge, and then don't merge it to df2, merge it to a copy of df2 where I renamed a few of the columns. Then it's an outer merge. And then instead of left on and right on, I just say on, and then I pass it a list of column names that now are in both spreadsheets. And finally, I put the indicator equals true flag on so that I could get that left only, right only, both output. And I merged it to CSV, and that's what that looks like. So that can be nice when you actually do want to know stuff about that's. I think outer merges are most common in transaction comparisons and in getting additional detail about people from various lists. But yeah, it's yeah. Mm-hmm. Or you can do the left on and right on, and then there'll be. You're saying the data in them. Yeah, like it has to be Maryland. Yeah, it has to be Maryland. In fact, in our output, if you look carefully, we have 2 Albert Howards, because one of them had an email address of ah@example.com, and the other one had other email at example.com. So as far as we're concerned, those are 2 different Albert Howards, different people, just based on the rules we set. We could have said we only wanted to merge on first and last name, and then we would have had him in the same row. Good question. Good question. There is it actually does have a way of handling that. It would have added it would have in the output, you wouldn't have had an email column anymore. You would have had email underscore X and email underscore Y as your output columns. And everybody who was only in spreadsheet 1 would have had a value in their email underscore X column, but not in their email underscore Y column. Everybody who was only in spreadsheet 2 would have had a value in their email underscore Y column, but not their email underscore X column. Everybody who had the same email address in both would have had the same email address appear in both columns. Because remember, in this case, we're only matching on first and last name. We're saying we don't care about the email. It's just a detail about these people. It's no longer part of the matching. It's just a thing. It's like their favorite food or where they work. It's just a thing. And then Albert would have also had email data in both email underscore X and email underscore Y columns, but he would have had a different email address in each column. Which is one reason why I try to take care of renaming my columns before I put them into the merge, so I don't get unexpected output in the merge. It's a matter of preference. Right. Yeah, extra steps before, extra steps after. Good question. All right, so let's see, did we have any more business cases? No, just those 3. So we are technically at time for when I said the lesson part of this would go till, but I also said that the thing, it's supposed to have a social hour for the last half hour. So we've got till 2:30 before I even said this would wrap up. Was anybody counting on skipping the social half hour? And does anybody want to stop? Okay. And then I've got this room till 3:30. So you guys tell me, I'll do another checkpoint at 2:30. See what you think, if you want to get on with your Saturday. All right, so we're going to do a hands-on together. And we've got 5 spreadsheets coming into this. But I wanted to make it kind of realistic. Here's what we got. We've got 3 Eventbrite exports of people who came to Python Salesforce 101 back in October, people who came to Python for Salesforce 101 online office hours in November, and people who came today to Python for Salesforce 102. They all are the exact same columns. They're spelled the same. That's nice. It's just literally exports of using the same tool, blah, blah, blah. And then we took our Salesforce org and we did a full table dump of contact, and we did a full table dump of campaign. And we're going to try to get everybody, we're going to try to build campaign members to insert.csv so that we can put everybody with their status back up into Salesforce saying who attended what. So questions about the business purpose of what we're doing? All right, so one thing you might notice real quick, we do have an ADA in our Salesforce, but we have AD at exampleoverhere.com, and we have DIMA at example.com in Salesforce. And in this exercise, we're going to match on first name, last name, and email. So for all practical purposes, ADA is not in Salesforce. Another thing is we have duplicate records for Juliana with that email address in Salesforce. So for all practical purposes, both of them came to anything that Juliana came to. There are things we could do to deal with that. You know, I recommend deduplicating Salesforce first. My personal business preference is just say that they both came to everything and deal with the deduplication later. Because one contact can only have come to one campaign once, so it's going to automatically deduplicate the campaign memberships when you deduplicate the contacts later on. So I say flag them both as having attended, deal with it later. Yeah. Yeah. So I've got some business rules in place for this example, and I just wanted to show you how clumsy it can get in the real world as soon as you actually hit real world data. And the things that we're going to do are going to produce things like Juliana attending twice, and that's okay. That's okay with me today. And we're going to end up creating we're going to end up creating a duplicate record for Ada when we load him into contacts because we couldn't find him. Whatever. All right, so first thing we're going to do is just deal with getting Juliana, because she's actually the only person, if you look carefully, we don't have Haskell Southerns in there, and we don't have Revka Lilburn in there, and we don't have Hermano within Shaw. These online name generators come up with some interesting stuff. They're not in our database. Fortunately, all of our campaigns are in campaign. We have Parasailing Fun Day, we have our 3 Python things, and we have Hockey Outing. But yeah, so we'll be able to find all of that, no problem. We're only going to find Juliana when we actually look by first name, last name, and email. And so first thing we're going to do is just make our campaign members to insert file with a contact ID, a campaign ID, a campaign member status, and then just for our eyes only. I mean, honestly, data loader just needs these 3 fields. The rest of it is an audit trail for us. So that's what we're going to make first hands-on. We'll worry about the next people next because they're a little more complicated. All right, so how do we want to do this? Do we want to do this? Does anybody want to do this or putz around on their own? Do we want to do it more like the shout it out like we did earlier? Shout it out. Okay, I'm going to open the, hopefully this, let's see. No, I don't want that. All right, so this SFPY 102 collab is hopefully still working. If you're online and you want to be in the collaboration with us, you'll want to go to that. Oh, good, we have Mandelbrother. All right, so let's make sure this is still working. I should be able to print. Hello. I hit run before I actually even had anything to run. All right, while we wait. How did I get way back there? SFPY 102 collab, as in collaboration. So if you're online and you want to join us, or if you're in the classroom and you get impatient waiting for me to type and you want to help, great, come on up to the board and type. So if you're logged into repl.it and you go to SFPY 102 collab, you should be able, so you should be able to live code. So actually somebody who's in there, just make sure it works. Hit enter after my print. Make sure you're in the white middle part. Yep, now we can see that Mandelbrother is editing my code. Oh, and Midwave is jumping in to help. All right, and when we settle down a little bit, we can run 102 collab. We'll put this thing to a test. I'm kind of excited. I think it's within like the last 3 weeks that they introduced this. All right, so okay, I'll hit run. We should get hello yo. Yay! Okay, good job, guys. So anybody is welcome to type. I highly encourage it. So we've got some steps, and I did actually put this. I don't know if when you guys scroll, it's also going. Somebody scroll back down. Is it like, or when I scrolled, did it change what you can see on your screen? Oh, great. Okay, I put the instructions here. I put the instructions on your SFPY info under example 4. And I also have the instructions in the slides. So trying to make it so there's lots of chances to have the instructions. So what we're going to try to do, first thing we want to do is just concatenate the Eventbrite sheets and save it as events DF. Ooh, nice. I like that. Thank you, whoever is putting the comments in as we go step by step. All right, so someone want to give it a crack building the events DF data? And oh, and just so you know, I should mention what I already have in there. I already imported Pandas, and I already gave you already have EVDF1, EVDF2, EVDF3, contacts DF, and campaigns DF ready to go.
First, you got to rename the event 3, right?
Do they have different columns between the 3 of them? Okay. There was a suggestion to rename the events 3 columns, but they should be all right. All right, so someone wants to just take a look at what's in our spreadsheets before getting started too far. Where is it? So, all right. So the output is we've got our hello, and then we've got this is Python for Salesforce 101, and then there's a list of all the columns that are in it. Python for Salesforce 102 and the list of columns, and Python for Salesforce 103 and the list of columns. So we can, if we look carefully, we can see that they do share the same column names with each other. All right. Do you want to leave those? That's going to show up every time we hit run if we don't comment it out. Do we want to comment it out maybe? Or backspace it out? Awesome. All right. So we want to build events DF. Events DF equals. And if you're looking, I should show you real quick. If you're looking for the syntax, if we go back to the top of today's stuff and we go to underneath exercise 4, I have 2 cheat sheets. So that's what we were just looking at, and so you can grab some syntax there if you'd like. Yeah, that's your SFPY 101. Or no, info. Sorry, SFPY info. Or you can just type that whole thing as you see it. All right, now you're seeing a blue and green screen? Awesome. All right, so Oops, that's the wrong one. Firefox. All right, we've got pandas dot. So far, we've got events df equals pandas dot concat evdf1. Now we're typing comma. We got a little bit more we want to throw in. All right, we're concatenating evdf1 and evdf2 and evdf3. And if we, looks like maybe that's a suggestion just to stop there. What would we want to do to actually see if that does anything useful? Right, print events df. Nice. All right, so I will come over and run it on my screen. Oh, it must be iterable. You passed a data frame. Yep, square brackets. Someone want to add square brackets? Correct. All right. All right, there we go. We've now, look at the row IDs, by the way. This is why they say they're not really row numbers. We have 0, 1, 2, 0, and 0 and 2. Exactly. They literally kept their IDs from their old identities in their old things. There are things we could do to renumber them, but to be honest, nothing we're going to do today actually depends on what the number of the row is. And even though they both say 0, if we were to do things like, do a, uppercase the last name kind of thing, I say that, like, when you punch in stuff where a series has the same row IDs as a data frame, it does stuff. Not necessarily the same to the naked eye. Pandas is actually keeping track of these. It actually knows that 1 0 is different from another. So I'm not too worried about that, but it can be confusing to the naked eye. So I just wanted to show you that. So there's our concat. Nice job, everybody. And our next steps. Thank you for loading it up. So we want to do a merge now from, we want to put events df on the left, and we want to put contacts df on the right. And the implication of doing an inner merge is that we're only looking for Juliana. We don't care about people who aren't in Salesforce. So, and then we're going to save it as merge one df. So merge one df equals. All right. So again, in that thing where I've got the guide to today's class, if you go up to the top, you can see merge examples. So anybody got us any guesses about how we might get started, indicating that our left data frame is events df? All right, just type events df dot merge. All right, and what do we want to merge it to? How do we specify that we want to merge it to contacts df? Just type contacts df. All right. All right. And then is left like a special keyword, or do we have to put it in quotes? Quotes. All right. And I'm just. Thank you. Good question. No, I did. You're right. I did say inner. All right. And I'm pretty sure we can't even run it this way, but let's see what would happen if we tried, having not finished typing it. Okay, it's going to yell at us. I'm going to come out to the old print. Oop. Oh, okay. Somebody found the events reindex. All right. Somebody wants to see what reindex does. I'm going to comment out our merge that we're building so it doesn't yell at us again. Oh, I think there are more things you have to do with the reindex, but yes, there are commands you can do to get it to go back to starting with 0 and moving up to 1 and so on and so forth. I am going to take out printing events df. Okay, so we have a little bit more we need to do to build this merge so that it doesn't yell at us when we try to run it. Does anybody remember anything else that a merge might need? Awesome. All right, how do you want to specify that? Left underscore on? All right, and then what goes to the right of the equals? like a list of column names? All right, so we'll do a square bracket because that's a list. And let's see. First, tell me if I'm typing these. I think that was how they were capitalized. All right, and then what would be next? All right. Yeah, and these are from data loaders, so they're all uppercase. All right. Shall we give it a try, see if it works? Yes, we do have to print it. All right, it's so wide, it's kind of wrapping around the screen. I hope you can see phone ends up on the second line of column headings, and like the phone numbers end up kind of on the second line of each line. But we've just got Juliana, and we have on the left, like the fact that she attended this event, and to the right, we have her details from Salesforce. And that whole thing I was saying about like, if you have Charlie in one spreadsheet and then you have Charlie drives a Volvo, Charlie drives a Subaru, you're going to get Charlie twice. You're going to get Charlie the Apple lover with a Volvo, Charlie the Apple lover with a Subaru. That's what's going on here. We now have two rows where the info from the left is kind of just repeated on the second line. And then it's different on the right. All right, so we got someone starting in on the next one. We want to delete the merge DF columns that aren't necessarily. All we really, really wanted from that whole context table was just her Salesforce ID. We didn't really care about her phone number, all that stuff. We don't need that second copy of her name that's in all caps first name. Oh yeah, the thing so that thing about the left on and the right on, if they have different things, you can see we have Juliana twice. Once at the far left under the word first, and again near the far right under the word first name. It's really redundant when you don't rename your columns before you put them into the merge. So, okay, let's see, we're trying to keep only certain columns. Okay. So from what, I don't believe there is any sort of syntax with data frames that involves parentheses. So I'm going to start just by changing this to brackets, and let's see what this does. We did merge 1df equals merge 1df ID. Oops, I'm going to actually get rid of this earlier print. So when we do that, with our first guess at how to delete everything but the columns of events DF and the ID column from context DF, what we ended up getting is a series rather than a data frame. And really what we got was the ID column. We got her two Salesforce IDs. So we'd like a little bit more than that. Let's try making it, for starters, a list, just to see if we can at least get a data frame out of this thing. So this is a single item list. So okay, now we've got a data frame that's just the ID column. So what are a couple of things we could do to also get those other columns we want? What else could we add to the list? Yep, we could just type them out one by one, right? Yeah. I'm going to do a fancy trick. Remember that thing where you could put plus in between two lists? I'm going to say events df dot columns. Oop, and I have to surround it with the word list because it's not by itself a list. And then I'm going to say plus, and then ID is going to be inside of a list all by itself. And now we'll run it. Yay! Is a longer list. Yeah. The sum of two lists is a longer list. I like that. All right, what was next? We're renaming, let's see, are we doing? Yeah, we're renaming the ID column to contact ID because we don't want it to just be ID when we're about to insert campaign members, or it's going to think that we're trying to insert campaign members, deal with like specifying IDs for the campaign members. We need to rename it to contact ID because we're going to upload to another table where the field is called contact ID. So let's do that. Yep, that sounds right. So to tell you the truth, I actually Google this every time I need to do it. So I don't have it all memorized myself. Okay. It looks perfect to me. Shall we run it? Oh, I guess we'll have to do a print. And we had someone add the merge one df equals at the left of our statement, which is good because otherwise it would have been that whole thing where we compute 1 + 1 and then throw it away. The thing on the right is a renamed copy. So we need to overwrite the original with that renamed copy. All right, so now we have that. And the final column is called contact ID. Yay. All right. You can kind of keep going with dots after dots after dots after dots. It just gets really hard to read. Yeah. Maybe I'm one. Fair enough. All right, I like what we're doing here so far. That right now, what we're starting with is just getting a skeleton together. It's like, okay, I remember I need to say what the second data frame is. I remember I need a how. I remember I need some ons. Love this. It's a great way to code. It's a great way to build Excel formulas too. Yeah. Yes. Okay, so the question was, we're working with CSV files and spreadsheets. Is there a fancier world in which we can pull this directly from Salesforce? And the answer is you're going to be working with the Salesforce API. It's a REST API. There's a package called requests, in just like there's a package called Pandas, and you can work with that. Salesforce will give you data not in CSV format, but in another format called JSON. Fortunately, JSON is basically just dicts inside of lists inside of dicts inside of lists, and you just have to learn a lot of Python for looping over those things, sort of like those comprehensions we've been doing. Also, pandas can read from those things if you get them structured well enough. There's a package called symple_Salesforce that takes away most of the dealing with the requests over REST. It takes care of that for you. It has a syntax where you just give it a username and a password. Number one thing about pulling data down live from a password protected system is not leaving the password in your code, and not even typing the password into your code on a system that you're not 100% sure is, like saving copies of your code for 30 days in some weird part of your system. You'll want to be skeptical and cautious. And I always name my Python files that do such things has password in all caps hyphen, so that when I do my final save of my file and I exit it, I'm just like, oh, right. Or, the other thing is a lot of the IDEs like that I use, they actually technically run my code not as an integrated program, but when I hit run a second time, it's like it still has all the variables in memory, as if I had just been typing on an interactive terminal, one line after another, only 10 lines at a time. And so that I take advantage of it sometimes, in that like I'll punch in the login thing, I'll save the authentication key I get back to authentication_key. I will immediately change my code back to not have my password in it and hit save. That password's still technically there as far as Python is concerned till I like close everything down, but at least I've already done my like saving my code work to make sure that I didn't leave it around for a month from now. Postman. Postman is Yep. So for online, we're talking a little bit more about how to manage passwords safely. While we've got, looks like Rachel has been hard at work building us a merge. You ready to give it a try? Okay, so we're gonna run the code so far that Rachel built for us while we all were talking, which is awesome because we got to do two things at once. And we have one problem, which is that there is not a happened on _C column anywhere in either of our tables. _C. Salesforce. All right, so there it is. Again, we've got a lot what we had earlier, only now off to the right, we've got ID, named, and happened on C, and ID is that campaign ID. In this case, there was actually only one row of the campaign that matched, but there were two things. This time there were two things on the left and one thing that matched on the right. So we've still got our two rows. It just served a little bit more like our country lookup in our first example of merging. All right, so next thing we're going to do, we've got two renames to do. We could do them both in one statement if you'd like. It's 2:30. How are people doing? Okay. Anybody need me to rush and wrap it up? Yeah, that's right. I was going to take a break after this, but do people want to take a break just right now? Or? Okay. We'll just, okay. Anybody who needs to. Okay. 5-minute break. Because we're very close. And a lot of what we were going to do was just, getting, I don't know. We'll talk a little bit about, all right, we gotta, yeah, we'll talk about what we would like to do as far as all this in a minute. Thoughts so far about what we've done? Is anybody feeling ready to give it a try at home? Yes. Nice. Well, just to blast through a little bit of what our next exercises had been, and that I'll save for 103 now. We were going to build. You're welcome. We were going to build campaign members. We're just about done building campaign members to insert for Juliana, but we were going to build another one for everybody else. Up at the top of the top of this, I defined a function called doFakeDataLoad, and it was meant to imitate. We were going to dump out the people who weren't yet in Salesforce. Sort of that thing you taught. We were gonna do that thing of finding people who weren't in it. We were going to do a left join and then take out anybody who said both, which would be Juliana. And then normally we would dump that to CSV, put it into data loader, get a new CSV back from data loader, and pull that back in. I defined a thing called doFakeDataLoad, which just attached random ID numbers to people and a status of item created, just to simulate that step. And so then we would have taken that, and it would have we would have already been off to the races. We would have called it merge 3DF, and we would have been off to the races, and we would have done all the same things as we did with merge 1DF and that we're doing with merge 2DF, because it would have looked just like merge 1DF had with Juliana's contact IDs.
You mentioned some middleware that you can use Salesforce sort of sift through the JSON. You mentioned
well, there's a requests module in Python, and then Python comes, and then you can do one called import JSON, which will give you a little bit of stuff. But for the most part, Python treats JSON kind of just like it does native lists and dictionaries. Anything that works on a dictionary pretty much works on JSON. Loops and stuff.
So getting from Salesforce to Python, so in my batch file, because I'm literally doing this just in my batch file, there's just a direct download link where you can create a skills and then have a direct download link. And it will just download that report to your downloads folder, and then you can move that report. You know, it's downloaded as a CSV or an Excel file. I prefer to use it as a CSV. And then you have that report, and then you can work with it. You know, so you have a report, the link, and then you get, and then there's just a direct download URL.
Yeah.
Is there, can I put that in some kind of an app file?
Yeah.
Is there an easy way to do that with Python to just access that direct download link?
Probably. I mean, yeah, it would be requests. Check in with me. I can walk you through setting up requests.
Okay. Are you doing office hours?
I will do an office hours. Okay, so we've got people who need to go. Anybody have questions that they want, that they want to say in front of everybody before they go? I want to make sure that. Thank you. Quick falling over my chair. Thank you. I'm glad it at least rolls out of the way.
So, from a speaking perspective, when you have a combination of sitting at a table and standing up, it's good that you walk about the room a bit. It creates a little bit more visual interest. But
Does anybody have anybody in the room? And I got some questions in the chat room. I'll look at it in just a second. But anybody who's zipping up have anything that they're just like, we didn't get to the end. I need to know this one thing.
Well, I kind of want to take this and then play around with my use case a bit.
Okay.
And then
Oh, I'll have a 103.
or something like that.
I'll do both.
Would I just watch
The meetup.
page?
Yeah.
Okay.
Great. Yeah.
Cool.
Keep an eye on the meetup.
Do it.
All right, we got questions in the chat room. For JSON, is there a way to do the standard entity message and fields format? I don't actually know that format, so I'll have to look into that later. And someone says, we convert exports into accounts. You're welcome. Insert an account name, for example, in JSON to load other systems when moving to customer status. I'll have to follow up with that one. Get a hold of me. Yeah. I'll put my I'll put my contact information on the page. You can tweet me at Katie Codes. Codes is with a K. You can DM me. We can follow up a little bit more about that, and I'll share it if I get an answer to it on the blog or something. Yeah, other questions about people who are just like, wait, I need to know this one thing before 102 wraps up. How do people feel about just finishing out this one problem and being done? Sounds like a good idea? Okay. All right, so we're renaming a couple of things. We're trying to rename merge2df just to clean it up to be a nice campaign member status file. All right, so we've already got a skeleton built out. I love this skeleton building you guys are doing. It's when I said this is just like building Excel formulas where you just sort of you start with what you know and then you find something else that can go in it. You guys have caught on to that so fast. I love it. All right, so we've got merge2df equals merge2df.rename, columns equals, and then we've got our little curly braces, and we gotta do inside the curly braces, we gotta do some of those something colon something, something colon something, something colon something things. All right, ID to campaign ID, and capitalization matters. All right.
And the status to campaign member status.
All right, excellent. Looks like, oh, yep, they are renamed. We just haven't gotten rid of our redundant columns. That's probably next. All right. We need to reorder fields and drop things that we don't actually care about. So how do we do reordering again? Merge2df equals merge2df. Open square bracket. Why would we need a second one? What does the second one do? Makes it a list. Yep. And so we'll say contact ID, campaign ID, campaign member status, last, first, email, event name, event date. Let's see if I typed accurately. Yay, we're so close. The only thing, it's not yet a file. Let's do the last thing. Oops, there is no step 11, it's step 10. All right, so how do we turn merge2df into a file called campaign member status records to insert? All right, so if I do this, have I done anything wrong? Quotes around it, thank you. All right, so if I do that and hit run, we're going to watch this files area at the left. Might take a moment. It's not always the it says it's done on the right, I can tell. It can sometimes take up to a minute to appear on the left. if it doesn't work here, I may open a new window and give it a try. All right, does it have all of our stuff we've been doing together? It does. Well, this is sad. I really wanted this part to work. One of you guys, come on. What if I run it again? Come on, files. Well, I promise you normally. The thing is, this is not an artifact of how slow Python is. It would have been instantaneous on my computer. It'd be there. It just, especially in group mode, it doesn't seem to like to work. I'm gonna share a different screen. If you get, I don't know. You guys need to see that it works. Would it feel satisfying to see it work? One thing I wanted to mention, I did want to show you the whole thing about like turning on and off the, how am I going to get this? All right. link.stthomas.edu/fsfpy collab 102 collab. Now Python is taking forever to fire up. Okay. We have, I'm going to end screen sharing over here for a second. And I'm going to share my screen. Thanks, Ben.
Yeah, looking forward to 103.
Yay, stay warm.
What do you think 103 will be? Just, maybe actually doing some web scraping or interacting with Salesforce.
Maybe that's hard to do as a webinar. It's hard to do interacting with Salesforce as a webinar because we need to type passwords on the screen and then put that on the recording. Right. I suppose we could make a dev org and just hope nobody breaks it. Doing some math. Oh, like statistics and pivots and stuff. Yeah, I had hoped to show off one of those. If anybody wants to see one, at the end of the notes, I've got a door prize script that's a pivot where we count how many times people came to each event. And you think so? So more than lower and upper and all, and a lot of text transformation. Okay.
Thanks again.
Removing white space. Okay. Replacing. People are copying and pasting. You don't find matches because the white space was there. Transforming dates into another format. Okay. All right. So I'm going to run this and put it in my CEA. And there it is. Now, as we wrote it, the one issue with it is that it's got this blank column with 0 and 1. So if we didn't want that, yeah, we do that index equals false. And now it doesn't have that. One more thing I want to show you. I'm going to hit run while I've got it open. See that huge dump of errors and then it says permission denied to this file? That means I had the file open while I was trying to write to it. So stop share. Did I already stop sharing? Did I ever have that on the screen? Oh. All right, so big error dump if you've got the file open. We wrote to CSV, and I opened the file, and there it is. And we had, before we turned on index equals false, we had an extra column that looked like that. So, ta-da. All right. Thanks for coming, everybody. We got through, if you want to see how we would have done the thing of building a campaign members to insert for everybody else, be sure and take a look at that SFPY info. And actually, I may change the link to that at some point, but I will share a link on the meetup about where I'm putting the video and everything. And I'm going to have all the same stuff that you had access to during class. I'm just maybe going to make the links last more forever. And yeah, so you can see how I would have gotten all those other people and see how I would have pivoted to count things. And we'll have to do a 103 where we do a little bit of pivoting in math and where we do some white space cleanup and playing with dates. I like that idea. And I hope that you guys will play with this on your own. Who here, who's left, has had a chance to install a Python environment on their computer so they can actually run it locally on real data?
You can install it without.
Can you?
Yeah, it installs it.
I need to screenshot the process of doing that. Okay, good to know. Okay, so people, I like Anaconda. It comes with everything, and it's just double clicking through a bunch of installation things. And then the IDE that I recommend, so Anaconda is like a suite of things, including making sure your computer understands Python and stuff. And then the IDE that it comes with that I like is called Spider. That's what I just showed you guys. It can also install another one for you called VS Code. Again, that's the text editor with a run button, whichever flavor you like best. Spider, yeah, Spider with a PY because it's Python. Yeah, so I would say homework would be get something installed on your computer. I'll announce an office hours for helping people just like step by step, like installing Anaconda with somebody else there in case anything goes wrong. But download these sample files from the web and run them on your computer. See if you can get them working. I haven't. I probably need to.
It beats everything by far.
Okay.
Like it's got GitHub built in. So it's just like
Salesforce is moving towards recommending it for developing triggers and stuff. Yeah. Very. It's meant to make Python able to imitate R. Yeah, it's got so much more stuff than we're covering because it's for statisticians. Yeah. All right. So yeah, guys, tweet me at Katie Codes if you actually do something nifty and do something a little different than we did in class. If you get the things we didn't get to working. How do people feel? Do we want to like do the things we didn't get to in 103, or do we want to just sort of leave them as stuff you can read on your own and ask me questions about when we move on to other topics? Yeah, like we were going to do one more sort of that we were going to start like filtering rows, and we were going to sort of selectively edit rows a little bit, and we were going to pivot just a little, and so it's like I don't know, like that whole thing, like building the campaign members to insert of people who weren't in there, doing a left join and filtering to just people who weren't in there. Do we want to actually hands-on all that and like really make sure we've got it solid, or just sort of you can practice it on your own and we move on to other topics? How are people feeling? You're happy to practice examples on your own? Okay. Yeah. Thanks, guys. Thanks, everybody online. What?